Hello everyone, in the previous video you learned how to find the inverse of a 2 by 2 matrix, and in this video we are going to take a look at the way of finding the inverse of a 3 by 3 matrix. We suppose that we have a matrix A with its following elements: A sub 1 1, A sub 1 2, A sub 1 3, A sub 2 1, A sub 2 2, and A sub 2 3, A sub 3 1, A sub 3 2, and A sub 3 3. There is a formula for finding the inverse of a 3 by 3 matrix, which is equal to 1 over the determinant of our matrix times another matrix, which is called the adjoint of the matrix in linear algebra. We suppose that this matrix is called B, so our following elements are gonna be B sub 1 1, B sub 1 2, B sub 1 3, B sub 2 1, B sub 2 2, B sub 2 3, B sub 3 1, B sub 3 2, and B sub 3 3. Okay, how do we find our elements? For instance, here B sub 1 1 is equal to the determinant of the matrix of ignoring of the first column and the first row that we are left with, which is A sub 2 2, A sub 2 3, A sub 3 2, and A sub 3 3. The entry B sub 1 2 is equal to the matrix of the determinant of our matrix of ignoring the first column and the second row. So it's gonna be A sub 1 2, A sub 1 3, A sub 3 2, and A sub 3 3. Okay. The entry B sub 1 3 is equal to the determinant of our matrix of ignoring of the first column and the third row, which is equal to A sub 1 2, A sub 1 3, A sub 2 2, and A sub 2 3. The entry B sub 2 1 is equal to the determinant of our matrix of ignoring of the second column and the first row that we are left with, which is equal to A2 1, A2 3, A3 1, and A3 3 here. The entry B sub 2 2 is equal to the matrix of ignoring of the second column and the second row that we are left with, which is equal to A sub 1 1, A sub 1 3, A sub 3 1, and A sub 3 3. The entry B sub 2 3 is equal to the matrix of ignoring of the second column and the third row that we are left with: A sub 1 1, A sub 1 3, A sub 2 1, and A sub 2 3. And entry B sub 3 1 is equal to the matrix of ignoring of the third column and the first row that we are left with, which is gonna be A2 1, A sub 2 2, A sub 3 1, and A sub 3 2. And entry B sub 3 2 is equal to the determinant of the matrix of ignoring of the third column and second row that we are left with, which is gonna be A sub 1 1, A sub 1 2, A sub 3 1, and A sub 3 2. Okay. And entry B sub 3 3 is equal to the determinant of the matrix of ignoring of the third column and the third row that we are left with, which is equal to A sub 1 1, A sub 1 2, A sub 2 1, and A sub 2 2. Okay, that's all we need to do. And about the signs, we know that the first entry is positive, and from here we change the sign. For instance, here is positive, so it's gonna be negative. Positive, negative, positive, negative, positive, negative, and positive. Okay. And here is an example. Find the inverse of the 3 by 3 matrix below. We have a matrix A with these following elements: 0 1, 2 4 3, negative 1 2, 0, and negative 3. First, in the first step, we need to find the determinant of this matrix, and I'm going to use the quick method. Okay. So we find the determinant of this part of our matrix, which is 3 times 0 minus 1 times 4, which is negative 4 here. And then we find the determinant of this part, 1 minus 6, which is gonna be negative 7. Okay. Then we find the determinant of this part of our matrix, which is 4 times 0 minus 2 times 3, which is gonna be negative 6. Okay. Then we find the determinant of this part of our matrix, which is gonna be 3 times negative 3, which is going to be negative 9 minus 0, which is going to be negative 9 overall, over our middle entry, which in here is 3. Okay. Then we find the determinant of this matrix, negative 4 times negative 9 minus negative 7 times negative 6, which is going to be 36 minus 42 over 3. So the determinant of our 3 by 3 matrix is negative 2. By using this formula, we have here 1 over the determinant of our matrix, which is negative 2, times the adjoint of this matrix. How do we find the adjoint of this matrix? Let's find it. Okay, the first entry is equal to the determinant of the matrix of ignoring of the first column and the first row that we are left with, which is 3, negative 1, 0, and negative 3. Okay, and the second entry is equal to the determinant of the matrix of ignoring of the first column and the second row, actually, that we are left with 1, 2, 0, and negative 3. Okay, and the next entry is gonna be this 1, 2, 3, and negative 1, and entry b sub to 1 is equal to the determinant of the matrix of ignoring of the second column and the first row, which is equal to 4, negative 1, 2, and negative 3. 4, negative 1, 2, and negative 3. Okay, and the next entry is gonna be 0, 2, 2, negative 3. Okay, and the next entry 0, 2, 4, negative 1. 0, 2, 4, and negative 1. Okay, the entry b sub 3, 1 is equal to the matrix of the determinant of the matrix of ignoring of the third column and the first row, which is gonna be 4, 3, 2, 0. Okay, and the next entry is gonna be 0, 1, 2, 0. 0, 1, 2, 0, and next entry 0, 1, 4, 3. 0, 1, 4, 3. And about the signs, we know that the first entry is positive and we change the signs. So it's going to be positive, negative, positive, negative, positive, negative, and positive, negative, and positive here. Okay? The determinant of this matrix is 3 times negative 3 minus negative 1 times 0, which is negative 9. Okay? And here 1 times negative 3 minus 2 times 0, and we have another negative here, so it's gonna be negative, negative 3, so it's gonna be 3. Okay, and here we have 1 times negative 1 minus 2 times 3, which is gonna be negative 7, and here 4 times negative 3 minus negative 1 times 2, which is gonna be negative 10. Actually, we have another negative here, negative, negative 10, it's gonna be 10. And here we have 0 times negative 3 minus 2 times 2, which is gonna be negative 4. And here 0 times negative 1, which is gonna be 0 minus negative 8. And we have another negative here, negative, negative 8, it's gonna be 8. And here we have 4 times 0 minus 3 times 2, which is going to be negative 6. Here 0 times 0 minus negative 1 times 2, so it's going to be negative 2, negative, negative 2, it's going to be 2 orally. Here 0 times 3 minus 1 times 4, it's going to be negative 4. Here we have 1 over negative 2 multiplied by this matrix. Okay, so we multiply it. So here we have a power negative 1 is equal to positive 9 over 2, negative 3 over 2, positive 7 over 2, negative 5, positive 2, negative 4, positive 3, negative 1, and positive 2, and